Hello, welcome. In this short video, let us look at the definition of continuous random variable. A random variable is said to be continuous if and only if its cumulative distribution function is a continuous function of value x. The cumulative distribution function is defined as the probability that the random variable x is less than or equal to the value x. That is, the CDF at a value x is defined by this probability. So some of the important properties of this cumulative distribution function are that the CDF at minus infinity is always going to be 0 and CDF at infinity is always going to be 1. I mean, these properties basically follow from the first laws of the probability, and the probability of an interval of a continuous random variable is equal to the difference between the cumulative distribution function at the difference between the CDFs at the ends. That is, probability of the random variable between the two values x1 and x2 is the difference between fx of x2 and fx of x1. This basically gives the expression for the calculating probability of an interval for continuous random variables. The key difference between the CDF of a continuous random variable from the CDF of a discrete random variable is that the continuous CDF is always defined for all values of x, and thus it has a derivative at all values of x, whereas for discrete random variable the CDF does not have a value or for all values of x. So for example, in this illustration we see a continuous CDF and also a discrete CDF. There is a CDF of a continuous random variable and a CDF of a discrete random variable. We can clearly see that the CDF of the continuous random variable is defined for all values of x, and clearly it is an increasing function. However, the CDF of a discrete random variable is 0 for values that are between these discrete points. And this plot is basically an example illustrating the CDF of a continuous random variable, which is defined as follows. That is, for values less than 0, it is 0, and for values between 0 and 4, it is equal to x by 4, and it is 1 for all values greater than 4. So from this definition, we can clearly see the first three properties, or the three properties of the continuous CDF. That is, the CDF is 0 and in minus infinity. So we can clearly see that for values less than 0, the CDF is definitely 0. And for values greater than 4, and hence the value at x equal to plus infinity, the CDF is equal to 1. And finally, the third property, the probability for an interval, that is for values between 2 and 3, is equal to the difference between the CDF function at 3 and 2, which is obviously from this definition equal to 3 by 4 minus 2 by 4, since the two values lie in this interval. Thanks for watching.